Good morning, children. Through the last video, we discussed about the laboratory preparation of HCl gas by reacting NaCl and H2SO4. The entire story we have discussed through the last video. Today, I'm moving forward with some more topics related with the laboratory preparation. The first thing is we preferred sodium chloride for the preparation of HCl over other metallic chlorides. Other metallic chlorides means there are so many other metallic chlorides like KCl, magnesium chloride, so many other metallic chlorides are there. Still, we prefer sodium chloride for the preparation of HCl because of two reasons. The one is it is very cheap and easily available in the market. तो सोडियम क्लोराइड इज़ प्रेफर्ड ओवर अदर मेटालिक क्लोराइड्स बिकॉज इट इज़ चीप, सस्ता भी है और हर जगह मिलता है, इसलिए हम लोग सोडियम क्लोराइड को ज़्यादा प्रेफरेंस दिया जा रहा है. दैट इज़ अ फर्स्ट पॉइंट. देन द सेकेंड पॉइंट इज़ फॉर द प्रिपरेशन ऑफ HCl we use concentrated sulfuric acid. Suppose somebody asks you why we are not using concentrated nitric acid in place of sulfuric acid. The answer is nitric acid we are not preferring because it is highly volatile. Volatile means the substance which can evaporate very easily. Those substances are called volatile substance. Suppose if you take a sanitizer in your hand, it evaporates within no time. So such substance we call it a volatile substance. Since nitric acid is a volatile substance, it is not used for the preparation of HCl. Okay, I think it is clear for you. Then the third thing about the preparation is we use a drying agent called concentrated sulfuric acid for drying HCl gas. There are two more common drying agents. One is P2O5, phosphorus pentoxide. Another one is calcium oxide, quicklime, CaO. These are other common drying agents, but we will not be using these two drying agents for drying HCl gas because of, again, with the two reasons. The first thing is it reacts with the HCl gas. Drying agents should never react with the product. So since these two drying agents react with HCl gas, these two will not be used as a drying agent. And one more thing, HCl gas, you know that it is basically acidic. So calcium oxide and P2O5, these two are basic or alkaline in nature. So basic drying agents we will not use for drying an acidic gas. So because of these two reasons, the first thing is it reacts with HCl. Second thing is P2O5 and calcium oxide. These two are alkaline in nature. Because of these two reasons, we are not using these two for drying HCl gas. Then the next point is maintaining temperature. The temperature is maintained below 200 degrees Celsius, and if the temperature moves above 200 degrees Celsius, what are the problems? Let us see. The first point is the glass apparatus which we use may crack or break at high temperature. That is why we are maintaining the temperature just below 200 degrees Celsius. The second thing is not that important, then also please by heart, fuel may be wasted. Then the third thing is see, normally when we react NaCl with H2SO4, the product is NaHSO4, sodium hydrogen sulfate or sodium bisulfite. But if the temperature goes above that, the product will be sodium sulfate, Na2SO4 will be formed. If Na2SO4 will be formed, the problem is that this substance will stick to the glass apparatus, and the apparatus we will not be able to use for further experiments. So the temperature we keep under 200 degrees Celsius because of three reasons. The first one is glass apparatus may break. Second, fuel may be wasted. Third thing is instead of NaHSO4, Na2SO4 will be formed, which stick to the glass apparatus. Then the next point you have to remember is about collection of HCl. HCl is collected over water. HCl is not collected over water because it is highly soluble in water. Good number of gases, for example, hydrogen, oxygen, these gases we generally collect over water because they are sparingly or they are not at all soluble in water. So we can collect hydrogen and oxygen, these kind of gases, over water. But HCl we will never collect over water because it is highly soluble in water. So each and every point which is given here, you need to focus very seriously. Then another thing about this experiment is again with the collection. See, HCl gas is a colorless gas. So the gas jar which we use, sometimes we may get confused whether the jar is filled with HCl or not. So we are doing all this experiment only for the collection of HCl. So you need to know whether the jar is filled with HCl. So for that, what we are doing is we'll take a glass rod. We'll take a glass rod and we will dip it in NH4OH. When you dip a glass rod in NH4OH, and you will bring that glass rod near the mouth of the glass jar. When you bring the glass rod here, the mouth of the gas jar or glass jar, if the jar is filled with HCl, if the jar is filled with HCl, definitely HCl will overflow. If it comes out, it will come in contact with the glass rod which contains NH4OH. If NH4OH and HCl, if it comes in contact, the product will be NH4Cl, and NH4Cl will give you a special appearance. NH4Cl will give you dense white fumes. Dense white fumes will be produced. If dense white fumes are produced, that shows that the jar is filled with HCl. Then immediately you will replace the gas jar and you will place another one there. Okay, this experiment is to come to know whether the jar is filled with HCl. Once again, we will take a glass rod and we will dip it in ammonium hydroxide, and when you bring near the mouth of the glass jar, if HCl is if the jar is filled with HCl, definitely it will come in contact, and as a result NH4Cl will be produced. NH4Cl will give you dense white fumes. This shows that the jar is filled with HCl. Then another point is, suppose if you expose HCl gas in air, it gives white fumes. It gives white fumes because of the formation of tiny droplets of hydrochloric acids. Sometimes during examination they may raise a question like this: why HCl is called as a fuming acid? Then you will say, when it is exposed in air, it comes in contact with the moisture. As a result, it gives white fumes. Hence, HCl gas is called a fuming acid. So please remember this point also. Then the next thing is about its physical properties. Physical properties, just casually you see, color is colorless, smell is pungent, choking, just a kind of a suffocating smell, and the taste is acidic in nature. So this will give you a taste called a sour in taste. Then density, HCl is definitely heavier than air. That is why we use the method called upward displacement of air for its collection. And about solubility, it is highly soluble in water. These are the major physical properties of HCl gas. And here is an experiment given to show that HCl gas is heavier than air. In this experiment, we have taken two glass jar. One is here, another one is here. Okay, the first glass jar contains a candle. A burning candle is here, and another jar we are taking. That jar contains HCl gas. Now see, this candle is burning, and when we keep this second jar with the HCl over the first gas jar, what happens? Since HCl gas is a heavy gas, what happens? HCl gas will come down and occupy this space. As a result, what happens? The lighter gas air is pushed outside from here. This experiment is to prove that HCl is a heavy gas. We have kept once again HCl gas on top. As when we keep it like this, suppose if you're pouring water from one glass to another glass, just imagine what happens. Suppose one empty glass jar is here, one glass you take, and if you have water in another glass, when you pour it, what happens? The water will come down and air will be pushed outside. The same science is here also, my dear. Since HCl gas is a heavy gas, पानी जैसे एक हेवी सब्सटेंस की तरह वो भी नीचे आएगा, नीचे आकर के पूरा स्पेस ऑक्यूपाई करने लगता है, उसके चलते ये एयर बाहर निकलने लगते हैं. तो जैसे जैसे एयर बाहर जाएगा, वी विल कम टू नो दैट द कैंडल goes off, that candle is get extinguished. That clearly shows that the gas which you have kept on the top, that gas already occupied the space of the lower jar. That is why air pushed outside. That is how the candle is getting extinguished. That's all for today, children. Thank you.